In part 4, we're going to take a look at using histogram for outlier analysis, how we can identify white space in our data set. We'll explore CTQ drill down and compare performance to specification limits. Okay, I've cleaned up the screen a little bit, and what we've got is our original table of data located right here. And we've taken the total lead time, or the two doorstep column of data, and plotted it out as a histogram. We'll be taking a look at histograms in additional debriefs of the pizza case, but other videos exploring how to build, create, and analyze histograms. But even without going and taking a look at those videos yet, I think for most folks, they can spot right away that one of the great things about histograms is that it quickly helps you to identify outliers in a data set. Now, or anomalies in a data set. You can determine whether or not they are indeed mistakes, anomalies that should be removed from current state analysis, or mathematical statistical outliers. And then from that, you can zoom back into the table to find out the actual record and explore and analyze further. Love histograms to help me identify and spot outliers. All right, I've cleaned up the screen a little bit here and zoomed in. I want to take a look at one of the records to help us to understand that there is some additional information we've got besides just the 5 columns of operational activity cycle time data, as well as the total lead time in the system. So our two doorstep column is the lead time in the system. But if we take the first 4 variables, call, build, bake, and package, and add them up and compare them to the cumulative 2 driver time, we're getting another variable associated with performance in the system. Here's what I mean. If we add up the call time of 3 minutes plus the build time of 2 minutes, the bake time of 9 minutes, the package time of 1 minute, we get a grand total of, do my math here, 3 plus 2 is 5, plus 9 is 14, plus 1 is 15 minutes. So the first 4 variables add up to 15 minutes. But if we compare that to the 2 driver time of 17 minutes, the difference between the two is 2 minutes. And that 2 minutes represents all of the idle time handoffs in between each step. We call this white space in the system. Idle time handoff, or white space. Now, we don't know if the white space is all between call and build, or if the white space is all between build and bake, or bake and package, or spread out equally amongst all of those variables, but we do know that there is 2 minutes in that particular record for white space. I'm not going to do it for every single record in this data set, but what I am going to do is calculate white space for the average. Let's take a look at that next. Okay, I've cleaned up the screen a little bit here and zoomed down to the bottom of the data set, and this is what we're looking at now. We've got average values across the 30 records, and call time of 2, build of 3, bake of 9, package of 2, and 2 driver of 17. Total lead time on average was 40 minutes. Let's take a look at white space. White space is just going to be the comparison of the 2 driver time of 17 minutes compared to the first 4 variables. And if we add up 2 plus 3 is 5, plus 9 is 14, plus 2, we're at 16 minutes. So the average amount of white space in this system, 1 minute. 1 minute. 1 minute. But we also can compare the total lead time of 40 minutes to the 2 driver time of 17 minutes. And the difference between the two is what I like to call the drive time, the delivery drive time. So let me clean that up and let's take a look at what we should do next with this information. I've got the screen cleaned up a little bit here with updated values for white space and drive time, and we can take a look at all the variables now and start to see a picture of what's really going on in current state. Of all of the variables, there's really only one variable, drive time, that is a significant contributing factor to the total lead time of 40 minutes. Other variables play a much smaller role, and what this helps to show is, first of all, white space, not that big of a deal. I know in a lot of the process improvement work that we've looked at in other courses, in other videos, we talk about those idle time handoffs as being a major factor to enterprise process frustration, process inefficiency. But in this particular case, we don't have a lot of it. It only accounts for about 1 minute of the 40-minute average total lead time that we've got. But drive time is a huge factor here, and it helps us to better understand a concept I like to call CTQ drill down. In CTQ drill down, with limited time and resources, it might be nice to try to capture information on all the phenomena that's happening in current state, but it's unrealistic. You just don't have the time or resources to do so. So you pick a few variables that you think are contributing. It's only after you do your first cut of this or first review of this data that you realize that one of the contributing variables is much more important than the others. Now, we could rank sort order the results. We could do a visual display of this rank sort ordering using a Pareto chart. We've got a separate video that describes how to create and interpret Pareto charts. But what it does show us is that the drive time is a variable that we need to explore further. We call it a critical to quality variable, but in the second cut of data that we collect, we now want to explore what are the CTQs that are influencing this CTQ called drive time. So new CTQs could include things like what's the staffing situation on our delivery drivers? What about the fleet vehicle maintenance associated with those drivers? We may be taking a look at distance or miles away from the pizza shop location. We could consider weather. We could consider time of day, day of year. These are now all CTQs that we identify from the drill down of one of our first CTQs, drive time. So now with this screen cleaned up a little bit, let's summarize what we found out. We've got a better data set of current state data available for us to use. We used a data collection plan to help get that better data. There were still some anomalies here. There were still some issues with sequential data that we needed to deal with, but we're in a much better situation than we were before. We've identified that there are some variables that are much more important than others, and if we had available time and resources, we may want to drill down on that and take a look at other variables affecting current state. When we look at overall performance using this visual display called the histogram, and we include in the histogram the specification limit, that's what this red line is right here. We can see that in the frown zone, in the outside of the upper specification limit, a good 75, 80% of the time, we're giving away free pizzas. That's bad for the organization, but on top of it, the customer is dissatisfied because they're getting a late pizza. If you exclude this outlier due to a mistake in data entry, we're taking a look at only about 15% of the time are we meeting customer needs. Clearly, we've got a poorly performing process. In part one of the case with a single data point, we didn't know if there was a business problem. Now we have a clear indication that there's not only a business problem, but we're also starting to realize what some of the root cause variables are that are causing the problem that we're seeing. in part 4 of this case, we'll take a look at using histograms for further analysis, as well as explore how variation plays a role in developing our future state solutions. All of that next.